Lesson 9.4, Graphing Sine and Cosine Functions. Our essential question: how do you explore characteristics, stretch and shrink, translate and reflect graphs of sine and cosine functions? Standard 9.4, Introduction. Exploring characteristics of sine functions. We're going to start off by looking at a table. I want you to use your calculator, and I want you to find what all these values are for sine at these particular x values. So go ahead and get out your calculator. We're going to fill in this table. You will observe that every pi interval, whole pi interval, when you type these into your calculator, you'll always get the answer 0. So sine at negative 2 pi is 0. Sine at negative pi is 0. Sine at 0 is 0. Sine at pi is 0. And sine at 2 pi is 0. All of the whole pi values are going to be 0. All of the halves are going to interchange between 1 and negative 1. Negative 3 pi halves is going to be 1, while negative pi halves is a negative 1. Pi halves is a positive 1, and 3 pi halves is a negative 1. All of the fourths are going to interchange between the square root of 2 all over 2 and negative square root of 2 over 2. So negative 7 pi's over 4 is square root of 2 over 2. Negative 5 pi's over 4 is also a positive root 2 over 2, while the negative 3 pi's over 4 is a negative root 2 over 2, and the negative pi over 4 is a negative root 2 over 2, continuing with the denominators of the 4. Pi over 4 is a root 2 over 2. 3 pi over 4 is also a root 2 over 2, while our 5 pi over 4 is a negative root 2 over 2, and our 7 pi over 4 is a negative root 2 over 2. Our 9 pi over 4 is a positive root 2 over 2. Now let's go ahead and graph the points that we just found in the accompanying table. So our first point was the coordinate point negative 2 pi, 0. Our next point was the negative 7 pi fourths, which is about here, and then it was positive root 2 over 2. Well, what is positive root 2 over 2? Positive root 2 over 2 is 0.707107, and the negative square root of 2 over 2 is going to be a negative 0.707107. So we're going to use those to help us find our points. So we were looking at negative 7 pi over 4, and we needed to go up about 0.7. So here's me going up about 0.7. The next point value was negative 3 pi over 2, and that had us go up a value of 1. Next was negative 5 pi over 4, and we had to go up root 2 over 2. Negative pi gave us a 0. Negative 3 pi fourths had us go down root 2 over 2. So we're going down root 2 over 2. It's about right here. Negative pi halves had us go down 1. Negative pi fourths have us go down root 2 over 2. 0 is at 0. So connecting these, this is what my graph ends up looking like. This is our graph for sine of x. The next thing it has us doing is it has us identifying a bunch of key points on our graph. So we're being asked to find the x-intercepts. We're being asked to find the x values for the local max and the local min. And then we're being asked to identify the intervals of increasing and the intervals of decreasing, but only between negative 2 pi and 2 pi. So let's go ahead and look at our graph. First, we're being asked to find our x-intercepts, and I was using green. X-intercepts are where we cross the x-axis. So this right here is an x-intercept, 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 x-intercept. So all of these green values are our x-intercepts. So this is at negative 2 pi, negative pi, 0, pi, and 2 pi. So let's go ahead and get that written down. We are now being asked to find our local max values. So let's go ahead and take a look at our graph. Maxes are the highest point of the mountain. So we have a max here and we have a max here. And it's only asking for the max's x values. So this would have been our first x value. This would have been our second x value. So let's go ahead and add it to our table. Now for your local mins. The mins at the bottom of the valley. So I see this min and I see this min. But they're asking us for only the x values. So this would have been the x value and this would have been the x value. So adding that to our table. Now we're looking for the areas of increasing and decreasing, but specifically we only want between these intervals. So looking at our graph, we don't want to include this point. We're literally just going from here to here. Where are we increasing and where are we decreasing? Remember, you increase when you're going up the mountain as you read from left to right. So I see that I am increasing here, but I stop right here at this value. I am increasing starting here and going up and stopping here. So start, stop. I am increasing this way, start, and I didn't stop. I would have kept going, but they're telling us to stop there. So we are going to stop there for now. So these are my areas of increasing. So for this area of increase, we know we're going from here to here. So we need an equation that represents this area right here. That equation would say, hey, look, I started at negative 2 pi, and I went from there to my negative 3 pi halves. That would be this area of increase. So this is our first increase statement. This was our second increase statement. I went from here to here. So you would say, hey, look, I know I started at this value, and then I traveled along, and I ended at this value. This would have been increase value number 2. Now our last interval, it started here and ended here. So I would say, hey, look, I noticed that I started at the 3 pi halves and I continued on until I stopped at the 2 pi. That would be the third increase interval. So I observe sine has 3 increase intervals. So let's go ahead and add those to the table. Now let's go ahead and look at the decreasing. Decreasing is when you're going down the mountain. So let's go ahead and look at our table. So here's our graph. Going down the mountain. I saw that I could start at this value right here and go down the mountain to stop right here at this value. So I have this area of decreasing. Same here. I started here, went down the mountain, and I ended here. So this right here would be my second area of decreasing. I have 2 decreasing areas. So how would I represent this? I started here, and I went ahead and I traveled along until I ended here. This is decreasing interval number 1. How would you represent this area? It's, hey, look, I noticed I started here, and I went down, and I ended here. This is decreasing interval number 2. So let's go ahead and add it to our chart. Our last question is asking us, is sine going to be even, odd, or neither? So you're going to say sine is, now remember, even meant that it looks the same on the left as it did the right. So looking at our problem, does this side over here mirror exactly this side over here if I were to fold it along this dotted line right here? It does not. So it cannot be even. Odd meant that if I turned it upside down, so have this burnt in your brain, if I turn it upside down, does it look the exact same? It actually does, which means it's odd. So our function is odd. So I told you to flip it upside down. That is the non-Matthew way of saying rotate it 180 degrees about the origin. That's how you determine whether it is odd or not. Now let's go ahead and review some characteristics of the sine graph. You will notice that all of our max values were always at the 1. So the highest point on our graph is always at 1, and that our mins are always at negative 1. So our sine is always wedged between the 1 and the negative 1 every single time. Let's go ahead and look at your sine again. You will notice that I see it is being repeated. It goes up and then down, and then another up and then down. It looks as though it's being repeated, and it is. It's a repeat. And the pattern that is repeated is this is your x-axis. It starts right here at your x-axis, and it goes up and then down, and then it starts again, up and then down, and then it starts again, up and then down, starts again. So that is our repeat. The last thing I want you to observe is the placements of your x-intercepts. They're always at whole pi values. The last question asks us to describe the end behaviors of the graph. So here's our graph. End behaviors tells us what these arrows are doing. Does this arrow continue to go up, 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 and never stop? Does this arrow continue to go down, 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 and never stop? That's not the case. We know it's going to go up to 1 and then turn back down again. Go down to -1. Turn back up, go back to 1. It's going to go, hey, 1, -1, 1, -1, 1, -1. It's going to keep going. So it's oscillating between 1 and -1. It's not actually going towards any particular value.